The tests, first of all, of the ones that I graded, pretty good. I think the average was a B. There weren't any major issues that I saw come up multiple times. So it was good. The biggest thing was in terms of issues with plugging in values for your variables when the value is negative, making sure to use parentheses correctly. Especially when you have something like this. X squared, if x equals -3, what's the value of x squared? 9. Right, what we need to do is take -3 and square it. X squared means take whatever x is and square that. If you write it like this, maybe you remember, maybe you do this slightly wrong and you still get 9, but technically if you write it this way, you should do the exponent first, 3 squared is 9, and then the negative. So be careful between these two. This is why when you're plugging in values for variables, you always need to make sure that you're using parentheses when they're negative. All right. Other than that, they looked okay. So, lesson 25, solution of equations. We're continuing with taking equations and finding solutions for them. What do we mean when we talk about an equation? What is an equation?
Equation is something that has an algebraic expression with an equal sign.
Two algebraic expressions with an equal sign between them. You got to have something on either side, or it's not an equation. What do we mean when we talk about solving an equation?
Solving an equation. Making it true.
Making it true. Why would an equation not be true?
Because sometimes it can be like have a variable.
Yes. If there's a variable in there, the equation will not always be true. In fact, it might never be true. But if there's a variable, if it's x plus 2 equals 7, sometimes that's true, and sometimes it isn't. When is this equation true? When
X equals 5.
When x equals 5. What about this equation? When is this equation true?
When x equals 1.
Yeah, this equation is never true. I'm not going to give you any equations that are never true. And then we also have equations that are always true, like this one. 2 plus 3 equals 5. It's always true. Okay, but when we have an equation, a conditional equation, which is an equation that's sometimes true and sometimes not, when we talk about solving it or finding what? What's the other term? You could say find a solution or find a...
Sum.
Starts with an R.
Come on.
Starts with an R.
Reactant.
It's a plant part. Root, right. Find a solution or root of the equation means find the value, or it could be multiple different values of the variable that make the equation true. Okay, now, let's say that we've dealt with equations like this, 3x equals 9. What do we do to solve this equation? We're always trying to get our variable by itself on one side of the equation. What do we do to get this x by itself in this equation, 3x equals 9? Divide by 3, because right now x is being multiplied by 3, so if we divide by 3, we'll get x by itself and cancel out. What do we have to do to the right side? If we divide the left side by 3, we have to do what to the right?
Divide by 3.
We also have to divide that by 3. X is equal to 3. Pretty straightforward.
Yeah.
The other type of equation, this was using the multiplicative the multiplicative inverse.
I was going to say
multiplicative identity. Multiplicative equality. We also learned about equations like this: x minus 7 equals -3. What do we have to do to get x by itself in this equation? Add what?
+7. and positive 7, 3.
Right, we add positive 7 to both sides, we're allowed to do that. X minus 7 plus 7 is just x. Negative 3 plus 7 is 4. All right. Now we're going to combine these two. What if we have an equation like this? 3x minus 2 equals 10. We're trying to get x by itself. Yes?
Alright, so first I think we should divide by 3.
Why?
Because it's 3x, which is multiplication.
Why do you think we should do that first?
Because that's x.
Yeah?
Carry over the minus 2.
If you carry over the minus 2, if
That
you
means
make
it
it
would
plus 2 on the other side, it's gonna make it 12, and we know that's 3 times that. I mean.
Yeah,
that's
so
it.
3. So
Right, so what do we have to do first to this equation?
Can we simplify? No.
There's no simplification to do, we can't combine any like terms here.
We have to carry over the 2 to,
What do you mean when you say carry over the 2?
well, because you can, if you add 2 to negative 2, it makes 0.
Yes.
And then add 2 to 10, and we get 12.
Right, so we add 2 to each side, we get 3x equals 12, then what do we do?
Then we divide 12 by 3.
Just divide 12 by 3?
Yeah.
Divide 3 by 3.
Yeah, we, over here also. Okay, we got our solution, x is 4. Notice, what did we do first? First we undid the subtraction, or the addition of a negative. Then we undid the multiplication. When we're solving equations, eliminate operations in reverse PEMDAS. Reverse PEMDAS. So it'll be, what, SADMEP. SADMEP.
What?
That's PEMDAS backwards, SADMEP.
Oh god.
It's a MEP. You know what a MEP is, right? And it's sad, it's a sad MEP. I don't know. It sounds like it could be a word, but I don't think it is.
It was something on a TV show. I forgot what.
Or maybe MEP is actually spelled like this. Maybe it's MEP, like this. MEP.
Like an amazing world of Gumball.
Alright, anyway, sad MEP is what we'll do when we're undoing things to get our variable by itself. Why? Because what this means over here, 3x minus 2, means first, we're multiplying x by 3, and then we're subtracting 2. So if we're undoing that, we have to start at the end and work our way back to the beginning. So first we're going to add 2 to undo the subtracting 2, and then we're going to divide by 3. So first we undo the addition and subtraction, then we undo the multiplication and division. After that will come exponents, and after that will come parentheses. We're going to go in reverse order of operations. Capiche?
Yes, Captain.
Okay. Let's do one or two of these examples here. Let's skip to example 2 at the top 107, negative 5m.
You said 107?
Page 107, yep. We've got negative 5m plus 6 equals 8. What do we do first to get this variable by itself?
Minus 6.
First subtract 6 from both sides. What do we end up with on the left?
2.
On the left, what do we end up with?
Negative 5m equals 2. Yeah.
Yes, negative 5m on the left equals 2. Then what do we do? Divide by? Divide by negative 5. Because notice m is being multiplied by negative 5 here. So we divide by negative 5 over here, so m is equal to what? Negative 2 over 5, yeah. It's just 2 divided by 5, and since one of them is negative, the whole thing is negative. What would happen if they were both negative? Yeah, it would turn positive when we divided them. All right. Let's do
Another one.
another one. Let's do example 5 at the bottom of 107. So we can practice using fractions. 1/5 m minus 1/2 equals 3/4. Don't let the fractions scare you, it's still the same thing. And as long as we remember how to add, multiply, divide. Okay, yeah, so here you're combining two steps. So he said add 2/4.
Yeah.
That works too, because we know that we're gonna have to add 2/4 over here, and 2/4 is equal to 1/2. So instead of adding 1/2 and then changing the denominators, great, we'll add 2/4. These cancel out, minus 1/2 and plus 2/4. Plus 2/4 is plus 1/2. Add 2/4 over here, all right, now what are we gonna get?
5/4, like 1 and 1/4.
What?
Keep it
5/4.
Yeah, so let's just leave it as 5/4. In general, improper fractions are actually easier to work with than mixed numbers. Mixed numbers are not particularly convenient. They're easier for us to understand while looking at them, right? It's easier to understand that 5/4 of a pizza is one pizza and then 1/4 of another pizza. But in terms of doing arithmetic, 5/4 is going to be easier to use. So we have 5/4 on the right, and what do we have on the left?
1/5 times m.
1/5m. How do I get m by itself now?
You divide 1/5 on each side.
We divide each side by 1/5. Because right now m is being multiplied by 1/5. So we divide each side by 1/5. Okay, so m is equal to 5/4 divided by 1/5. What does that become?
4/25.
4/20.
5.
Okay, how do we divide fractions?
It's gonna be
3 words. I want to hear 3 words. It's not stop, drop, and roll. It's what? Keep, change, split. Okay, so keep. So what do I do to keep?
Keep 5/4
Okay, change,
times
flip,
5/1.
times 5/1. What do I get?
25/4.
25/4.
I'm pretty sure that's it.
Oh,
Or 6 and 1/4. You can write either one of those. 25/4. Keep, change, flip. All right, let's see. Let's do an annoying one. Let's do, on page 108, let's do example 6. 0.4x
Oh my god.
minus 0.2 equals negative 0.16. Now, we're not going to do this the way they showed in the book. The way they showed in the book, that works. But there are a few things in algebra that I hate. Somebody names them the things that I hate.
Subtraction.
I hate decimals. Yes, that's one of the things here. What else do I hate? Subtraction, and I hate division. I hate division, subtraction, and decimals. I like fractions. I like addition of negatives. Okay, those are all good things. But division, subtraction, decimals, no. I don't like them. I had a student a few years ago. It was, I think, my second year of teaching, and I taught him right after lunch. And every day he would come into my classroom and start to chat with me by saying, "Mr. O, you know what I hate?" And then he would start telling me what it was that was irritating him that day. Anyway, okay, what can we do to this equation to make our lives easier? Because I hate decimals.
Maybe not
I know.
decimal.
But make them into just move over the decimals so they turn into whole numbers instead of half.
So we could make them fractions.
Or we could.
Fractions are okay. They're not great, though. They're not as good as integers.
But if you move over the decimal place.
Right. One thing that I can do when I have decimals is I can choose to multiply everything by some power of 10. When I multiply by 10, my decimal point is going to move and let me get rid of those decimals. So what power of 10 am I going to multiply everything by?
10.
Not 10,
1.
100.
100.
The reason why I'm going to multiply by 100 is because notice here, I'm going to have to move my decimal point 2 places.
Oh yeah,
Yeah.
That's why
So if I multiply this by 100, what do I, and notice I'm doing the same thing to both
40.
sides.
You get 40.
So I get 40x minus
20.
20 equals
Negative 16.
equals negative 16. Notice how one of the things I'm allowed to do is multiply both sides by the same number. In this case, I picked 100. Negative 0.16 times 100 is negative 16.
Oh my goodness.
On this side, remember, when I use that rule to multiply both sides, I have to multiply every single term. So I don't just multiply 0.4x by 100, I also have to multiply negative 0.2 by 100. All right, so now I've got 40x minus 20 equals negative 16. Yay, no more decimals. All right, what do I do first?
You
Add 20.
you add
Add 20 to both sides. Okay, what am I going to get? I like writing this line after each step.
Yeah.
Right? I have the original equation, then I write what I'm doing to it, and then I write it again. This is like the equals, the equals line when you're doing addition or subtraction.
40x equals 36.
40x equals,
no, it doesn't equal 36. It equals 4.
Oh, that's negative, yeah.
what's negative 16, so we're 16 over to the left is 0, and then we're going to go 20 to the right.
It equals 4.
Positive 4, yes.
Yeah.
So why don't you?
Right, remember when the signs are different and we're adding them, we subtract, and then it takes the sign of whichever one has the larger absolute value. So we do 20 minus 16 is 4. Since 20 has the larger absolute value, it's positive 4.
Wait, I have a question.
Yes.
I thought we were
Test corrections are supposed to be due today for the previous test.
Divide.
Divide both sides by 40. Okay, divide by 40. Divide by 40. What do I get? X equals
4 over 40.
Okay, can I simplify that at all?
Divide them by 40.
Oh,
1 over 10.
Right, 1 over 10. Or if you want to, because the original problem has decimals rather than fractions in it, you can rewrite that as what? What's 1/10 as a decimal?
0.1.
Yeah, 0.1. Okay, either one of those is fine. I'll take 1/10 for one of these. But don't, in the book when they show it to you there, they add the decimals and then they divide by decimals. I would not bother with that. I would get rid of your decimals first because I hate decimals.
Yeah.
They're un-American.
Yeah.
All right?
Yeah. I'm on his side.
I like me some good old fractions. All right, questions about this lesson?
No.
For homework, it's going to be numbers. I think it's the whole thing again.
No.
But
No.
this is, nope, I'm wrong. All right, so 25,
Skippy.
25. So this time it's except, so it's all of them except for 4 and 29.
Scoobity bop bop bop.
So you have almost all of them.
Scoobity bop bop bop.
But, all right. Over here with the patriotisms. Yeah, you know me. All right, bye.
Hey, which one looks like it has